Hello there, Mr. Sutton here, bringing you this lesson on cosine and sine. In particular, we are going to be finding exact values of these two trig functions using the unit circle. We're going to have a couple warm-ups on this one. The first warm-up, we're going to go through some basics of working with angles. So here's an angle, 5 pi over 6. That's an angle in radians. Your task is to convert this to degrees, find the reference angle, and then convert it back to radians. Pause the video and see if you can do that. Alright, so when you're converting between radians and degrees, the key here is you have to multiply either by 180 over pi or pi over 180 degrees. And to figure out which one you're using, whichever unit you want to convert to, that should be in your numerator. So if we want to convert this to degrees, we need to multiply by 180 degrees over pi. Now here the pi's are going to cancel. 180 divided by 6 is 30. And then 5 times 30 is 150 degrees. That's the way to do it without having to use a calculator. Now, for reference angles, we're basically talking about the distance between your angle and the closest x-axis angle. So it helps if you've got a circle as kind of a reference to help you with reference angles. So here's a circle with some various angles. 150 degrees is over here somewhere. Now, the closest x-axis angle is 180 degrees. And to get the distance between 150 and 180, you're just doing 180 minus 150, which gives you a reference angle of 30 degrees. Next, to convert this back into radians, we have to multiply by pi over 180. This is really pi radians, but we never write the word radians. So that's going to be basically 30 over 180 with a pi up there, which we can reduce to pi over 6. For the next part of this warm-up, we're going to talk about cosine and sine specifically, and we'll start with the question of what do you know about sine and cosine of theta? How are they defined? All right, so you might remember that cosine is adjacent over hypotenuse from SOHCAHTOA, that was ka, and sine, that was so, that was opposite over hypotenuse. Now, where this is going to get kind of interesting is let's look back at this circle. Let's say we have an angle on this circle, and this angle is actually hitting this circle at a specific x and y value. I'm going to draw a triangle to kind of capture all this. So here's a triangle. We've got this angle. Up here is a specific x and y value. And now on this triangle, this bottom side here, this corresponds with this x value. This right side here, this height, this is going to be your y value. And then the hypotenuse of this right triangle, this is actually the radius of the circle, which we will call r. Taking a look back at cosine and sine, in light of this, how could we define them? Well, cosine, that's going to be adjacent over hypotenuse, so we could call that x over r. And then for sine, which is opposite over hypotenuse, well, that's going to be opposite, which is y, over the hypotenuse r. So y over r is now our new definition for sine based on y value of an angle. We're going to dig a little deeper with this circle business. In trigonometry, we often don't use just any old circle. We use something called the unit circle. This is a circle that has a radius of 1. So up, down, left, right, 1 in every direction. And also, if you were to draw an angle on this circle, the terminal side, the radius, the hypotenuse of a triangle, if you're thinking back to SOHCAHTOA stuff, it's all 1. That means that your cosine is no longer simply x over r. Your cosine is now x over 1. And your sine is no longer y over r. Your sine is y over 1. So we could define cosine as, well, this is just x, right? Cosine you could think of as just the x value of your angle on the unit circle. And sine you could think of as the y value of your angle theta on the unit circle. So this point on the unit circle, we could call this cosine theta common sine theta. Now you might be wondering, well, how useful is that if it only works on the unit circle? And occasionally we'll have to remember that cosine is really x over r, but most of the time we are just working with the unit circle. So this is a very helpful and fast definition. Now that we've got a definition of sine and cosine, let's investigate some values of these functions, and then see if we can use those to put together a graph of what they look like on the x and the y-axis. So let's talk about positive and negative first. We know the actual numbers of sine and cosine at the four quadrantal angles, 90, 180, 270, and 0 or 360. But how about the sine, the signage, the positivity or negativity of sine and cosine in between? So cosine in quadrant 1, that's going to be positive because your x values are positive. Thing to keep in mind with the unit circle, this is just a circle drawn on the x and the y-axis. This is the x-axis here, this is the y-axis here. So cosine, your x values, is going to be positive over here. And sine, your y values, will also be positive up here. Now as you move over to quadrant 2, we're on the left side of the y-axis, so now cosine is negative. Sine is still positive though because we're still above the x-axis. Moving down here to quadrant 3, we are negative for sine and cosine. And over here in quadrant 4, now cosine's positive again. We're on the right side of the y-axis, but we're below the x-axis just like in quadrant 3, so sine is going to be negative there. So now, let's go ahead and use this unit circle to graph sine and cosine for our quadrantal angles. So take a sec, see if you can do this on your own. All right, let's see what we came up with here. So starting at 0, and we're going to do cosine first. The cosine, the x value on the unit circle at 0 radians, that's going to be this 1 right here. And then at pi over 2, well, now our x value is 0. If we go over to pi, 180, now it's negative 1 for the x value. And down at 270, back to 0. Yes, there's a pattern here. Going back to, this will be 360 now, or 2 pi. That's going to be 1 again. And it's going to keep repeating 0, negative 1, and then 0 again, and then 1. So this is what cosine looks like if you actually graph it out. You may have seen this curve before. This is the reason this keeps fluctuating up and down, because you're basically just looking at x values as you go around a circle. It's always going to alternate between 1, 0, negative 1, 0, and 1. Let's do sine now. So take a sec to calculate where we should put our dots for the sine function, the y value of the angle. Do you have it? All right. At 0, sine, the y value is 0. So there's our first dot on the origin. And then moving up to pi over 2, we've got 1. At pi, we're back to 0. At 3 pi over 2, now it's negative 1. Back to 360, 2 pi, that's going to be 0. And that repeats. We've got, again, 1, 0, negative 1, 0. Draw that curve in there now. Oh, will you look at that. They are different functions. However, you might notice, ooh, that's kind of neat, that sine is really just, cosine is really just sine shifted pi over 2 or 90 degrees. So if you shift sine this way by pi over 2, you've just got the cosine function. These are both cyclical. Keep repeating over and over again, forever and ever in both directions. And you also might notice that the range of y values here, it oscillates between negative 1 and positive 1, but can't go outside of that. And that is due to the nature of the unit circle. The unit circle, you might notice, you can't get any x or y values greater than 1 or less than negative 1 on there. In addition to being able to find cosine and sine at the quadrantal angles 0, 90, 180, and 270, we also need to memorize special values of cosine and sine at 30, 45, and 60. These are the most commonly called upon angles whenever they want you to figure out cosine and sine without a calculator. Now you can actually derive these values using special right triangles with a hypotenuse of 1, but in practice people don't derive these from scratch every time. They memorize them and just have them kind of ready to go. So to help you memorize them, I've got this little table here. We've got the 3 special angles here and cosine and sine. Now these values, the nice thing is they follow a pattern. So for memorizing these are all going to be the square root of some number over 2. The denominator is always going to be 2, so we can fill in 2 in all our denominators. So here, 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 something over 2, something over 2. So if you ever end up with something not over 2, double check your memorization. Now how about the numerator? The numerator is going to be the square root of a number between 1 and 3. And for cosine, we're going to start at 3 and count down. So this right here is the square root of 3, square root of 2, and square root of 1, which is just 1. For sine, we just count up. So we've got square root of 1, square root of 2, square root of 3. So we got cos down and sine up. So this will help you memorize this. At the very least, you could get this table and kind of recreate all the values really quickly and have it to use on whatever test or quiz you need to do. Now that we've gone over some of the basics of what we're doing with trig functions, here's a few Quizlets you can go to help you memorize some of your trig facts. So here's a Quizlet for converting from degrees to radians, converting to reference angles, and also another one for getting your special values of sine and cosine. You can think of these as kind of the ABCs of trig, without which we can't do bigger and more complex things. Now that we've memorized some values of cosine and sine in the first quadrant, we're going to use that to help us in the second, third, and fourth quadrants. Now the key to doing this is reference angles. Remember, a reference angle tells you basically how far you are from the x-axis in whatever quadrant you're in. So an important fact here then is that an angle is going to have the same absolute x and y value as the x and y value of whatever its reference angle is. So we're going to start by figuring out the reference angle for whatever they're giving us. For example, 120, what's the reference angle on that? Well, 120, that's close to the 180 end of the x-axis, so 180 minus 120 is going to give us 60 for that reference angle. Now the other important piece of this is that x and y values can be positive or negative if you're not in quadrant 1. So we have to figure out which it is. To figure that out, to figure out the sine of cosine, which is again the x value, or of sine, which is the y value, we're just going to look at what quadrant the angle is in. For example, here, 120, that's the second quadrant. That is to the left of the y-axis. We know that the x values over there are going to be negative. Therefore, cosine is going to be negative because that's the x value of an angle. So when we rewrite this, we can rewrite this as negative cosine of the reference angle of 60. And now we just have to know what the cosine of 60 is. That's going to be 1/2. So this is going to be negative 1/2. We're going to do a couple more examples finding exact values of sine and cosine without a calculator. Pause the video and see if you can use everything we've learned today to figure out these two values. All right, let's see how that worked out for you. So we'll start by finding the reference angle for negative 30 degrees. Well, that's just 30 degrees from the x-axis in the negative direction. So that is a reference angle of 30. And cosine, the x values in quadrant 4, those are going to be positive. So I can rewrite this as positive cosine of 30 degrees. Now we know that cosine of 30 degrees is just radical 3 over 2, so that's our answer for that one. Now for this next one, it would help if you convert this to degrees first. So let's see here, 180 divided by 4 is 45, times 5 is 225 degrees. And the reference angle on that, we're pretty close to the 180 line. So this is actually 45 degrees past 180. So this is kind of like sine of 45, except that sine, the y values, those are going to be negative in quadrant 3 because we are below the x-axis. So I'm going to rewrite this then as negative sine of 45 degrees. So then this is just going to be negative radical 2 over 2. So that'll do it for this one. Till next time, this is Mr. Sutton signing off. Or am I co-signing?